In the previous video, I just talked about why the binomial distribution formula is what it is. But in this video, I just wanted to talk to you about how it links to the binomial expansion. This is something that OCR love to play on, so if you are on that board, please do pay attention. So in the previous example, we talked about X being the event that we roll a dice 4 times and get a 2. If you've not seen it, please watch it first. And we said that the parameters of that event are n as 4 and p as a 6th. Another way you can visualize the binomial expansion from here is your p plus 1 minus p, which is 5 over 6, and you take it to the power of n, which is 4. If you don't know your binomial expansion, I'm just going to kind of explain the patterns. If you're aiming for an A or A star, you shouldn't really be looking at the formula sheet. You should be able to spot patterns. So the first term is 4 choose 0. Your 1 over 6 to the power of 0, which is just 1. We don't usually write it in. And 5 over 6 to the power of 4. The second term is 4 choose 1. And your 1 over 6 has power 1, your 5 over 6 has power 3. Then you've got 4 choose 2. The power of 1 over 6 increases and the power of 5 over 6 decreases. And then you've got 4 choose 3 and 4 choose 4. This is the expansion of 1 over 6 plus 5 over 6 to the power of 4. One of these probably looks familiar to you because we talked about it, but the probability that x equals 1, where you roll the dice 4 times and you get 1, 2, you can kind of see that here. This is the probability that x equals 1. So in a very similar way, this would be the probability that x equals 0, 2, 3, and 4 for the last one. So what the binomial expansion is doing is telling you what the probabilities are for every single outcome. If that's getting 0 2s, 1 2, 2, 3, or 4 2s. And if you think about it, the entire thing would add up to 1. And you can see that here anyway. 1 over 6 plus 5 over 6 is 1. Raise it to the power of 4 is still 1. So what the binomial expansion does essentially is it writes out all the probabilities of all the various outcomes in your distribution. For OCR, you do need to know that if you're given a binomial distribution like this, you have to know how to write it in this form here, and vice versa. I don't really see it too much with the other examples, but I guess you could learn something anyway.